This is an old free response question on polar coordinates, and it's kind of a good one. I'm going to zoom my graph in just a little bit, and I'm only doing part A. Parts B and C concern some parametric things and motion things that we haven't quite learned yet, but we will come back to this question. We'll revisit this once we have learned those things. This is the graph of the polar curves r equals 2 and r equals 3 plus 2 cosine theta are shown. The curves intersect when theta is 2 pi over 3 and 4 pi over 3. Okay, so this is right here. I'm going to draw this like this. I always like to draw lines because remember, we always reference from the origin, right? R is the distance from the origin, theta is distance from 0 radians. So this must be 2 pi over 3, and this must be 4 pi over 3. I like to just draw that intersection, okay, kind of like that. Now it says let R be the region inside the graph as shaded. Find the area. Well, there are a number of ways you can do this. One way would be to find the area of the whole circle and subtract this piece out. Another way would be to find the area of the circle right in here and then add in the piece, this little piece there. Another way would be to find the area of this piece and then add in this piece. That would actually probably be the easiest. And then, of course, double your final answer. Here's what I'm going to do. I'm going to do this in two parts because I just kind of want to show how I think, this requires some extra skill, and I want to show that. I'm going to find the area of the red piece. Now, that's the circle. I'll do it in red down here. So remember, you got 1/2 integral of r squared. So, that's easy. The bounds are the hard part. Now, here's the tricky thing. Remember, bounds must go from smallest to biggest. So it's tempting to say, well, they gave us the bounds. It's 2 pi over 3 to 4 pi over 3. The problem is, if you put the bounds as 2 pi over 3 and 4 pi over 3, 2 pi over 3 to 4 pi over 3, that will give this piece of the circle. And that's not what you want. So what I'm going to do instead is I'm going to rewrite this bottom bound with a negative angle. It's negative 2 pi over 3. That's the same as 4 pi over 3. And that way I could make it go negative 2 pi over 3 to positive 2 pi over 3. Notice my bounds are going the correct way. They're going from smallest to biggest. And now they're tracing. Here's negative 2 pi over 3, like that. Now occasionally I'll have someone say, well, what if I went 4 pi over 3 to 8 pi over 3? That would work too. You just need to go from smallest to biggest, and you need to make sure it's tracing correctly. Again, let me just explain why going from 2 pi over 3 to 4 pi over 3 isn't going to work. If you went 2 pi over 3 to 4 pi over 3, you would be tracing this pizza piece right here. You'd be going this way. We want to trace the shape this way. Okay? Now, this little part in here is a little bit easier because, of course, here we do want to go from 2 pi over 3 to 3 pi or to 4 pi over 3. Okay? Just like that. And then, of course, we would just add our answers together. That would do it. That's a great way to find this. Now, earlier I said there were a number of ways to do it, and I said one of the ways that's really popular, and I know this from teaching this in the past, is people to just say, you know what, I'm just going to go from 0 to 2 pi over 3, and then I'm going to go from 2 pi over 3 to pi on this other piece, and then I'll double my answer. And that's not a bad way to do it. The reason is then you don't have to think about this negative angle at all. You don't even have to think about it. You just say I'm going from 0 to 2 pi over 3, and I'm going to just double that. Okay? That's not a bad way to do it at all. It maybe saves you the trouble of thinking about this negative angle.